Welcome to this session of the Highway Capacity Analysis video series. We have 5 sessions that we're working through, and the third one is this one about multiple period analysis and how important it is in a signalized modeling, especially when things are congested or when movements have different peaking characteristics. I'm going to try to answer these questions. The big one is, are you collecting actual demand data and not just stop bar counts? You need to know how many cars want to go through, not just how many are getting through. Are you analyzing congested signals? If you are, then the multiple period analysis is imperative in order to get this answer correct and the results right. Otherwise, they can be not just wrong, but very, very wrong when it comes to computing delay or estimating back of queues. The Highway Capacity Manual 6th edition and the Highway Capacity Software Release 7 are implementing all these procedures, and the current and up-to-date Capacity Manual is research built and peer reviewed, so as defendable as you can get. The Capacity Software is faithful to the manual, always implementing it right up until any votes approved changes and updates are made available to users. This is the first thing that people need to know, and this has been around for about 20 years. If you're doing a planning analysis, then using the peak hour factor with an hourly volume to convert it to a 15-minute flow rate is probably okay. But if you're doing an operations analysis, the manual says don't do that. You don't use the peak hour factor. You model each 15-minute period independently. To overcome the peak hour factor dilemma with periods peaking at different times, different 15-minute periods, and much more than that, oversaturated conditions, spilling traffic from one period to the next, building and dissipating over time. So here's the peak hour factor, and what has been the case at some point in the past is that the peak hour factor was modeling each movement at the intersection differently. And if they peaked at different times, that was incorrect. And so to correct that, the latest manual says 1 peak hour factor for the intersection, but if you have movements that peak differently, suppose you have 3 movements coming out of an office complex and everybody gets off work at 5 o'clock, that first period is going to have a peak hour factor. Those 3 movements are going to have a peak hour factor about 0.4, where all the other 9 movements might have 0.9. So you need to do it by movement to overcome that dilemma. And then the next reason is unmet demand uses initial queue, and let's talk about that. First of all, collecting data correctly is very, very important. If you go out to a signalized intersection, you count cars. If you count them going across the stop bar, and that's all you count, and it's really congested, then you're going to be counting capacity, and your volume to capacity ratio will be 1. If your volume to capacity ratio will be 1, running through this procedure will generate almost always a delay of 90 or 100 seconds or so. But if you're out there counting cars and you notice that the average car for 15, 30, 45 minutes, 60 minutes is waiting through multiple cycles to get through, and the cycle length is 120, 150, 180 seconds, then those vehicles' delay is nowhere near 100 seconds. It's closer to 200 or 300 seconds. And that gets calculated incorrectly if you're only counting stop bar count instead of counting actual arrival rate. This little simple example here shows 2 periods that are undersaturated. In this example, this movement has a capacity of 500. In the 3rd period, I had 500 cars go across the stop bar, but 25 additional cars got there within the period. They just didn't get processed. So the arrival demand is really 525 for period 3. In period 4, that same 500 gets across because that's the capacity. It's never going to go more than that. But 25 of those vehicles actually were left over from period 3. So only 475 new ones plus the 75 at the end of the period generated an arrival rate of 550 for period number 4. You have to count the unmet demand at the end of each 15-minute period, the beginning of red for each approach. The beginning of red, you don't want to queue that the red light generated, you want the queue that's unmet demand from that period. If you collect that data and play this little arithmetic game I just described, then you end up with arrival rate, and that's what you need to model. The manual says that arrival rate, that peak of the yellow line in this graph, the yellow line plotting the fourth column, the blue line plotting the stop bar count, is where level of service is. There's a tool available within HCS called McTrans that allows you to count that unmet demand, plays the arithmetic game for you, saves the file that the streets module in HCS can read directly, so it actually makes your job easier. This tool will also count heavy vehicles and parking maneuvers and pedestrians and bicycles and right turn on red and all these other pieces of data you need to model the intersection correctly, store them into that same file, and populate your data set automatically. The manual says if you do a single period analysis, you're missing the initial queue delay. That 25 vehicles here causes delay to the first vehicle in period 4. So those 25 cars in front of him cause him initial queue delay, and that's D3 delay. And the manual says, look at the bracket on the left, that's if you ignore the initial queue delay, and the bracket on the right is if you include it as appropriate. Big difference. We did a study many years ago, and the results are here on the right. With a BDC ratio a little over 1.5, doing this incorrectly will yield 100 seconds of delay. Doing it correctly will yield 372 seconds of delay. So that's 6 minutes, 6+ minutes, is closer to the real world when you have a 1.5 BDC ratio and people waiting through 3 cycles to get through. The same thing occurs with queue. 1.5 generates a 23 vehicle queue if you do it correctly, a 10 vehicle queue if you don't. You don't want to model this, decide that the left turn lane should be long enough to handle 10 vehicles when, had you done it correctly, you would have built it for 23 vehicles. Conclusions: always count demand. Always run a multiple period analysis. If there is no unmet demand, your counting job is easier, and the multiple period analysis will yield the same answer. No harm done. The tool will pull the data in automatically anyway. So you should always run multiple period analysis, but you always have to count that unmet demand. If it does exist, play the arithmetic game and get arrival rate. Even if it's unsaturated, modeling 15-minute period by 15-minute period overcomes that peak hour dilemma that I described a few minutes ago and avoids operation decisions being incorrectly, or even planning decisions being incorrect if you model something in a single period instead of a multiple period analysis when it's operationally intended. Operations, by the way, means design, means signal timing, means optimization, means traffic impact studies. So the impacts here are, as I mentioned about the turn length, if you get that wrong, going to build it wrong. Optimizing signal timing needs to be modeling the signals as they operate in order to pick the correct cycle length splits and offsets. Here's a big one for the government. If the engineer for the developer does this incorrectly and shows you 100 seconds of delay with the development in place, and you say you have to pay to mitigate that down to 70 seconds, maybe that costs them $100,000. But if they had to mitigate 372 seconds of delay down to what you require, that might cost them $1 million. And that's the correct thing. If they pay $100,000 and put those improvements in, you're going to be stuck with the $900,000 just because they ran the model incorrectly. A big, big difference. The traffic impact fees could be way underestimated if you do this incorrectly, not to mention the time drivers sit in their car and the fuel that they're burning if you don't set the signal timing and optimize it correctly with this multiple period analysis in place. So we looked at multiple period analysis today. There are 4 other topics that we have in our set of 5 videos, and hopefully this was helpful to you today, and you might consider looking at some of these others as well. Here's contact information from me. I'm always happy to answer a question or discuss something with you, please give me a call or send me an email if you think there's any way I can help in any way. Thank you.